So my name is Marko, and today I'll be talking a little bit about Android beyond the phone. So what that really means to me, at least, is the alternative uses of Android. So using Android in places that are not what it was initially designed for. And I'm going to be speaking mostly from my own experience, working on some projects. So I'll tell you more about that as we keep on going. Before we get started, I just kind of want to get a sense of the audience. How many of you are Android developers, have developed something for Android, an app or something? So it's about a quarter of the room. Okay. And the rest of you are Linux developers, C, C++ developers, embedded systems, that kind of stuff, right? Okay, perfect. Cool. So that's a pretty typical audience that I deal with. And I'm just going to share some experiences. Again, this is a little bit about myself. I'm an author of a book that just came out the other week called Learning Android. And this is mostly about developing apps. So it's not so much about embedded Linux nor embedded Android. So it's mostly about application development. But I have worked on many projects that, like I said, are using Android in places that are not what it was initially meant to be used for. So roughly what we're going to talk about is why Android. So why are companies looking at Android as an alternative to whatever else is out there? So that's going to be one thing we're going to discuss. And then the other thing we're going to discuss is basically some case studies, some places that I've seen companies take Android and make a system out of it and make something useful. And you may or may not even know that it's powered by Android at the end of the day. So that's roughly what we're going to go through. So the advantages of Android, there are many advantages of Android, right? It's a portable system, it's open, this and that. But the items that I picked here are the items that are relevant to using Android in places that are not traditional users of Android, right? So we're not here comparing it to iPhone or BlackBerry or something like that. We're really comparing it to, and I guess an alternative would be just using a straightforward embedded Linux type of system. So one of the advantages is that it's open. So it's an open platform. It's relatively easy to get the source code to it. It's relatively easy to modify. Second big advantage is that it's got apps. So Android has a concept of application development, and it's a concept that sort of a lot of developers are embracing and understand and can build on top of that. So we're going to talk about that. And finally, it's a complete stack. So that's also an important consideration. So I'll talk a little bit about that as well. This is what it means to be open. How many of you have seen this tweet from Andy Rubin? Just a couple of you? Okay. So this was Andy Rubin is the guy who created Android Inc. and then subsequently sold it to Google and is now VP of engineering at Google and probably the most important person in the world when it comes to Android because he's running the show basically. And this is his response to, I believe, Steve Jobs or Steve Jobs saying how Android is not an open platform. And so this was just a tweet. So basically, 160-character definition of what it makes to be open. And what it is in a nutshell is what it takes to build an Android from source. So you make a directory, you cd into the directory, you pull down the source, you run make, and that should be it. There are a couple of minor steps here that are missing. Anybody notices anything that's missing as if the gingerbread honeycomb versions? Source? Lunch? Anybody? Exactly, yeah. So a couple of commands are missing. I don't know if that would fit into 160 characters, but it's still pretty cool. So nonetheless, Android is pretty open. Now, this is something that lately a lot of people are asking about. Well, is it really? Because when we think of a traditional open source project, we think, GitHub, just go pull down the source, and I have basically whatever was checked in the night before. And Android doesn't quite work that way, and the way it works is not quite clear going forward. We saw that recently with Honeycomb, where the latest version, the tablet version of Android, not being released, or its source not being released anytime soon. So those are some things that are sort of, big corporations that are embracing Android are sort of, starting to worry about this because they don't quite know what the strategy is going to be, and it is a concern. So that's just, putting it out there, it is something that people are concerned about. Second advantage of Android was that it's got apps. And what I mean by that is that, there's a model for developing applications, which means there are thousands and thousands of developers out there that know how to develop apps for your new platform, whatever that platform is. So that's thing number one. And thing number two is that there are already so many other apps out there that are available. Now, what I'm talking about here is a Android beyond the phone. So what that means is we're using Android in a non-standard ways, and I'm not concerned about passing the CTS, basically the test that ensures that your version of Android is gonna run all the subsequent applications. So we're not concerned about being by the book when it comes to running everything and anything that Android has to provide. But still, many applications are there, and they may run on your modified version as well, which would be a big bonus. So that's the whole point of that. And the thing number three is the stack. So it's the entire stack that we need for an operating system. How many of you have seen this picture in one way, shape, or another before? Most of you. Okay. So basically, what we have at the bottom of it, as you know, we have Linux. So that is basically the Linux part of the stack. Now these lines are perfect and cut and so forth, but in reality, everything's sort of mixed up when you start looking at the source code, like Karim demonstrated earlier. So when you look at the source, it's not so pretty as it looks here. The second layer here is basically the libraries. A lot of libraries here are copy-paste from other open source projects, maybe slightly modified. But these are the things that we needed to complete the stack, things that we needed to have the entire platform running. And most of these things that I have sort of up to here, most of these things are basically in C. So this is the C++ native code, essentially, right? Everything above this line is roughly Java, right? And what we have above this line is we have the application framework. So the application framework is basically what makes Android app development so interesting, because it's a very rich set of frameworks. It makes life of a developer fairly straightforward. You want to develop an app that knows its location, you just tap into the location manager and figure out your GPS coordinates, for instance. So makes it really straightforward to develop end user applications using the application framework. And at the top of the stack, at the end of the day, we have apps. So these are the things that the developers write at the end of the day. So that's what makes Android a complete stack. And when I say it makes it a complete stack, this is unlike some other alternatives out there that we have. Java ME, for instance, or if you just take a plain old embedded Linux sort of version and install it, it doesn't quite have all the moving parts that make it easy for somebody to just adopt it and build apps on top of it. So that's one big advantage of Android. So moving forward, what I'm going to talk about are a couple of case studies of using Android in places that are not typical phone things. And I'm going to basically talk about the enterprise version of a tablet and how that works out. I'm going to talk about using Android for public safety, so using it for connecting various devices to ensure that we're all safe in emergency situations. I'm going to talk a little bit about the military use of Android. Set-top boxes, there are a couple of cases there. Cars, that's one of my favorite. And anything else that may come up that didn't fit anywhere else. So I'm gonna talk about that. Now, most of these things are projects that I actually worked on myself, but because I can't really talk about, in some cases, information is not public, I'm not gonna be sometimes mentioning who the company is and so forth. So just so you guys are aware of that. So this is a project where Android was used to power a multifunction printer, scanner, copier, right? So it's one of those big multifunction devices out there, and this particular client basically wanted to create the entire user interface using Android. So before that, they had their own sort of homegrown system, and they wanted to explore how Android would fit into the picture. So what was appealing to them in this case was that there was the app development framework. In other words, why would they care about this? Is it that we're going to go to our printer and download some apps from the app market? Not very likely. So that's not really what was going to happen. But what's appealing about this is that a company can now create a development program and can basically go out to developers and say, hey, we have this device and we have this framework, and yes, you can also easily write apps for this device. So that's something that's very, very appealing to them. And that's something that's very straightforward in the Android model, right? Because right from the get-go, it was designed in such a way that we're going to have multiple versions of Android, right? Even in the phone universe, nobody gets a consumer phone with a vanilla Android on it. There's just no such thing, right? You have either a Verizon customized phone or T-Mobile's customized phone or HTC or Samsung or Motorola and something like that, right? So we all run customized versions of ROM on our devices as is today. And in this case, that was one of the important considerations as well, because the developers could now hack the printer and build their own apps on top of it in a safe, secure manner, because there's a model of how to do that. Of course, Android comes with a whole touchscreen thing figured out, and everything's there. So there's not a lot that needs to be the client needs to worry about in this case. It's got all the graphics, so none of that needs to be recreated. It's already there. The API is there. The framework is nicely, elegantly packaged and easy to use. And in this case, it also had networking. That was something that was important. So it was important for the printer to be able to just expose itself on the network, be findable, and that it also works with other devices on the network. So what was missing? What were the pieces that were missing when it comes to developing a solution like this? Well, obviously, they needed some custom drivers because they have their own proprietary piece of hardware. Now, there was a workaround around this as well that for which they may not have had custom drivers. So I'll talk about those two strategies in a little bit. They had some libraries because they wanted to expose some of these drivers to the developers. So if we're going to open up a printer to developers to hack in a safe way, we're not going to expect from them to talk to the drivers directly. It doesn't work that way. The way it works is you basically create a library, and a C library, and that's basically what's abstracting the hardware underneath that. On top of that library, you then build a set of API extensions so that the app developer can elegantly write Java code that talks to the app extension, that talks to the library, that talks to the driver. And I'll talk about that on the next slide, so you'll see what I mean sort of in lines and circles sort of way. So that's the framework support. And finally, at the end of the day, what we needed is we needed an app. We needed a single application that's going to run on top of this, this device. In this particular case, it's done in such a way that you may never know that this is an Android device. To you, it just looks like a touch screen. You touch, and that's it. And ultimately, what it is that we wrote a home app. So basically, just like Android system boots up into a particular home app, maybe your default one called the launcher. In this case, we created a custom home app that just had buttons, print, copy, scan, for instance. So there's no navigation bar, there's no drawer for the apps, there's no shortcuts, none of the standard Android things, right? So it was just basically a very simple app, and it was also the home app. So by just booting it up, it goes into that app, and there was nothing else on it. So that's that was the finale, that was the user interface in this case. So this is I'm kind of like taking the picture of a stack and kind of like pointing bits and pieces that we might have had to modify if we're doing a project like this. And I'm not going to get into any code or anything like that in 45 minutes, but I just kind of want to talk about conceptually how bits and pieces fit together. So like I said, at the end of the day, we had an app. There was an application, which was the home application at the same time. We wanted to provide a framework for other developers so that other developers may at some point create their own apps for this particular multifunction printer. So to enable that, we had to expose something via the app framework. So remember, this was the Java realm. So we're basically creating a Java framework that is going to enable that. This framework may or may not be part of the system services. There's something called a system server, and I'm sure you guys have seen Karim's talk on that. And that's basically, you have these Java services. Many of them are running at the same time, but some are sort of very important, and we call them the system services because they are what enables the system to run. So you may plug in your custom service as part of the system service or keep it separate. It's up to you. There are advantages and disadvantages to both approaches. So basically what we're doing is we're enabling this app to talk to this service. Now, for this framework to work, this framework needs to be backed by something that is native ultimately, right? So in this case, we wrote an SO, a shared object, a library here. So this is loading, talking to that library and loading that library up, right? This library may live in, for example, slash external, or it could be in systemlib folder, or even better, vendorlib folder, for those of you who were here in the previous conversation. So if you're modifying the platform, you would probably put this library in /vendor/lib. That way, as the new versions of Android come along, your code would be future safe, future proof, I guess, in a way. And ultimately, you may have some custom drivers for your particular platform that your library would ultimately need to talk to get the job done. This was one approach to doing this. Another approach that they looked at is actually using a web services to talk to their custom drivers. So basically, they said, look, we already built our embedded Linux realm thing that powers this device. How about we just leave it headless and expose it via a set of web services? And that way, so basically in that approach, we may have a whole other system running here and a mini cloud that would basically do a web service call to that embedded Linux system, or it could have been even this way, for instance, right? So that would be another approach to getting something like this done, right? So that's the multi-function printer case. Here's another solution. This is a much sort of bigger solution. It involves many moving parts, but basically it's a public safety concern, right? So it's a major OEM developing a set of systems for to enable emergency crews in cases of catastrophe and such to communicate, right? So this is a life or death sort of situation. And you have a lot of moving parts. You have the trucks, you have the vehicles, you have the people on the emergency crew on the ground, you have the command and control centers. So there's a lot of moving parts. And at the same time, you have a lot of different devices. Some are laptops, some are maybe building fire devices, some are mobile devices, and so forth. So we need to connect all of these devices, and you also have a very non-homogeneous type of network. So how do you do that? What are the concerns here? Now, what was appealing, again, for Android is that, again, it's a complete stack. So a lot of things that we need are already available there. We have the working networking. We have the working radio. We have the screen. We have the ability to create applications and so forth. So basically, the entire stack was there that was needed for this. Also, there's a lot of hardware off the shelf that you can pick up for this case. In this case, so for example, if one police department wanted to use one type of handheld radio, they can. Another department may choose another type of manufacturer, and so on. Everything works. Everything's happy. And it's also the application abstraction. So basically, writing an application doesn't interfere so much with creating the rest of the moving parts in this particular case. So if you're building a command and control center, as long as you know it's Android, somebody else can be working on the actual app that's going to, at the end of the day, run on the device, because we understand the separation model between the app and the actual framework, because it's well known, well published. So that's what was intriguing about Android in this case. What was missing was a couple of things that you need in a life or death situation. So basically, you need a priority of services. There are certain things that just are more important than others, right? So for example, radio must be up, must be working, and it cannot be it cannot be interrupted by, say, for example, some game or some notification thingy or some SMS message or something like that that's maybe more consumer related. So in other words, Android was designed for consumer, for mobile phones, and now we're sort of tweaking it a little bit to use it in a case where certain things must have higher priority. So that was one of the concerns, understanding the prioritization of internals of the system. Also understanding what the critical services are, which services are allowed to run, which ones are not. For example, media service is critical on a standard Android. Is it critical in a life or death situation? May not be, right? Whereas some other services may have to be more important. This is a pretty standard missing piece for a lot of these guys, and that's basically a control over apps. So now if you develop this device and you give it to many different public safety employees out there, what's stopping them from hacking it and downloading their own games and suddenly taking this like critical device and installing games and other social apps that are not so important on a device like this? So how do you tighten that? How do you prevent apps from being installed? Or how do you allow only certain types of apps to be installed from a certain trusted sources? So that's another sort of missing piece in this case. And also security. How do you make sure that this is used in the way that it was meant to use because it may have some sensitive information on top of it? So the solution sort of looked like this. So they're basically custom apps that were developed that serve different purposes in different situations. So these are custom apps. Again, we understand this app building model quite well. So this is a good big plus because you can just outsource it. You have somebody else build it on top of your framework. We modified the system server, the system service, right? So basically, certain things were taken out, certain things were changed in terms of priority and so forth. And also, it was expanded with custom services. So there are sort of custom services that are added to the platform that enable things that you may not have on a standard device. For example, GPS is not the only location mechanism out there. There's some other mechanisms that exist as well. So in a case of a government, maybe there's a way to plug into certain infrastructure that's not available to a regular consumer. So those types of custom services would be also added to the device. That may require modified libraries and custom libraries because ultimately this is being served by this guy and this is being served by that guy. And in this case, I left the Linux space empty because the idea is that we already just ported this to a device, so we have a working Android to begin with. So we're not really doing anything in terms of the customization of the driver space or anything like that because it is a just off-the-shelf device, more or less. It might have been rugged so for public safety use, but it's just a standard device. So that's a public safety case. Moving on, a very similar case. This is the Department of Defense, and this is one that's public information. So basically, DoD came up and said, "Hey, we want to give every soldier and every DoD employee a smartphone, 10,000 personnel, right?" And they basically built this lab right next to NSA in Maryland, and that was non-classified, and basically said, for experimenting with different carriers and different devices, so everything from BlackBerry to Android to iPhone, and kind of looking at which solutions make sense. One of the constraints that they wanted to kind of address is that they wanted a device that is, again, off the shelf. So they're not going to spend hundreds of millions developing a custom phone when they can just buy one relatively inexpensively. So what was attractive about Android is that you can buy this cheap device, you can take this entire stack that's free, and you can just tweak it to serve the purpose. So this is an example of using Android in a sort of modified way as well. It's more or less still a phone, but it's a very specific use of such. So again, it's off-the-shelf hardware, open source platform. Those were the attractive bits and pieces. Big developer base out there, which means it's relatively easy to hire if this takes off. Inexpensive solutions. So this was a big one because in the past it used to be that the consumers receive technology from the government. Now it's going the other way around. The government is actually taking a lot of solutions from the consumer space and adopting it for their own solutions. So that's a good thing for all of us. So the missing pieces here were device management, for instance. Now Android has been addressing this more and more so since Froyo and Gingerbread, but way back when I worked on this project, it wasn't possible to wipe a lost device. It wasn't possible to track a device. It wasn't possible to enforce password security on a device, right? Or password policy and things like that. So these are all the sort of enterprise things that are very, very important to the government use. Device management. And BlackBerry had that for a long time. Android didn't. But Android's fairly quickly catching up in that realm. So obviously security is really important to them. And when it comes to security, such a big word means lots of things to lots of people. But what the government was basically looking at is how do we make sure that the phone is being used by the right guy, right? How do we make sure the credentials are there beyond just username and password? And ideally, they would just like to stick something into a USB port to authenticate itself, right? Or Plan B would be to use something like Bluetooth technology to have a wireless authentication that the device is being used by the right person. So those were some certain things that they were looking at. And at the time, off-the-shelf devices with off-the-shelf Android did not have the USB drivers exposed to the upper layers. So basically, doing something like this would require quite a bit of hacking and possibly modifying the device itself. So that was one of the concerns. Priority of service, same as the public safety. App market locking. So how do you make sure that the government phones or government devices only receive apps from the government-approved store, for instance, right, or marketplace, whatever you want to call that. So those were some concerns. They're basically obviously interested in developing some kind of proprietary market, a place where you can go and download the apps. Now you're seeing a lot of sort of similarities between public safety and DoD stuff, and obviously a lot of them are duplicating the efforts, which is not necessarily a bad thing. Ultimately, we're going to get the safer solution, but that's something that was going on out there. So the solution sort of looked like this, very similar to the public safety. So we had the modified system service, we had some custom services for mainly to support device management, like I said. So device management itself. Package manager was modified to basically prevent certain applications from being installed or allowing others, basically checking the signatures and things of that nature. Custom libraries to support custom framework bits and pieces. Modified libraries to support modified bits and pieces in this framework. So it's always like this. This is supporting that, right? And then ultimately some custom apps that were enabling the end user to get the job done. So that was the military solution. Which brings us to another type of use of Android. In this case, it's Cisco. How many of you are familiar with CS project? Not many? Huh, that's strange. So Cisco is building this public information. Cisco is building basically the iPad for business. It's a tablet for business. It's essentially, it's going to be just like the picture, it's going to look like your phone, except you're going to go and you're going to grab that thing and you're going to take it out of its docking spot, right? And you're going to walk around and you're going to still maintain the conversation with the person or video chat and all that in real time. So, and that's basically powered by Android. So this is one of the very cool sort of enterprise uses of Android in this case to enable corporate America to basically use it for business. And in this case, the attractiveness was that it's open and portable, so relatively easy to port it to a new device, new gear. It's an open platform and can be modified. They're sort of rethinking this now that honeycomb source is not going to be available. So that's actually one of the concerns for a lot of people, like I mentioned earlier. What was attractive is, again, complete stack. It's all the things that they do not need to build, or again, because it's already there, available for free in Android. So those are attractive things. This was also a big deal. Having a wide set of apps already available for the platform makes it very, very attractive, right? So if Cisco went and created something from scratch, they would not have a developer support. They would not have the app market support out there like they do. Just embracing Android. So that's definitely a really big deal in this particular case. And also developers. So having a lot of developers out there making sure that that more apps are being created for this platform. The missing pieces were enterprise apps. If you compare Android to the other two sort of ecosystems, the iPhone and the BlackBerry, Android certainly lacks in terms of the enterprise applications. It's catching up really fast, so the speed of change is really good, but the sheer number of apps is not as great as might have been. So this is one particular place, where a lot of people are now swarming and making things happen, which is a good thing. Device management, again, prior to Gingerbread wasn't there, wasn't up par. Now it's getting much better, but that's something that Cisco was also sort of considering. Should we embrace it and do our own version? Should we wait for Android to come out with their own sort of built-in version? And this is where Google is not really helping by not saying what they're up to for 6 months plus, right? So that's a concern. In an enterprise setting, security is a concern. Support for enterprise market apps. So basically, Cisco is not building this for users just to go to your regular Google Android market and download spyware and things like that. They want to create their own enterprise market space, which is going to vouch for applications which are of higher caliber, basically enterprise apps. One of the interesting modifications to the basic platform was the support for multi-user. I thought this was interesting, especially for you guys being embedded Linux guys. Because standard Android doesn't really have a concept of a user. I mean, we have it in the Linux space, but we don't have it in the end user space, right? So what Cisco was interested in doing is creating a concept of a user so you can actually log in and multiple people could use the same device. So that's something that I thought was very cool. We did not have a SIP support in the older versions of Android prior to Gingerbread, so that was something that was also a missing piece, and video conferencing. So now a lot of these pieces are available in the newer versions of Android, but it's sort of, it's one of those, if you're building something for the future, you don't know when Google's going to come around, and they're not really announcing that either. So that was, the solution basically looks like this. Lots of custom apps, device management recreated, communication services added to support VoIP, things of that nature, modified system services, custom services to support some other things, and then obviously this is built on a custom hardware. So that was work in the Linux space as well. Next, what we have is the second last. What we have here is Android being used in the TV set-top boxes. And I worked with at least 2 major manufacturers on various projects that are basically Android in 3 major manufacturers, Android in set-top boxes. And this has nothing to do with Google TV, for those of you who are familiar with Google TV. As you know, Google TV is still not available as an API, so we can't really do anything as developers in terms of this. So basically, TV set-top box is using Android. So the attractiveness of this was that it's a complete platform again. So there are a lot of things given for free that make it really easy for developers to adopt this and build a platform around it. It's a quick-to-market solution, so it's a relatively straightforward to port Android, to wrap it up, to create a solution, to put it on the market. And I'm sure many of you are seeing that we're now having a whole slew of set-top boxes being available on the market that are essentially Android-powered. And everyone's doing sort of their own homegrown solution on top of Android, and nobody's still using Google TV other than the ones that Google partnered with, such as Sony and Logitech, right? The missing pieces were the UI that was designed for the mobile wasn't particularly friendly to users on a TV, right? We had a different type of experience, different type of a keyboard, different type of a relationship to a device, and so forth. So a lot of manufacturers had to create their own versions of the UI to enable this. Now the good news is that this is relatively straightforward, because from get-go, Android was designed to support a variety of devices. So that's a good news. But the bad news is that everyone had to create their own version of such a UI. Now Honeycomb addresses a lot of those things, but Honeycomb wasn't available until then, and it's still not available in source. There's some other things such as picture-in-picture that needed to be addressed, but there are solutions around that. Streaming and DRM support in Android is still not up par with what it needs to be for a lot of these manufacturers, so they invested a lot of energy usually around this realm, so adding more support for managing the content, because this is their value add. So they're not hardware manufacturers per se, they're solution people, so they wanted to basically be able to provide more content from more sources, and that requires DRM and streaming. So again, so in this case, we had some TV-related services that we added to the framework so that custom apps can be developed. Again, every OEM would like to create a developer program, basically have other developers contribute their own platform. So that's why you do not do this, but you do this. You basically make it available as a nicely packaged Java framework. Again, in this case, we modified some system services, and we added some custom services for various things. And finally, one of my favorites is using Android in cars. So basically, this is a project that was done by a company called Visteon. They're spin-off from Ford, I believe. They make a lot of sort of electronics in the cars that you may not even know it's made by them, including stereos and such. But this is a prototype of a dashboard that was fully powered by Android. And it's actually not just the dashboard, but it's the middle console as well. So in this case, we have a multi-screen sort of environment. Now, what's really amazing about the car industry is that, I don't know how many of you followed the whole Toyota fiasco last year, but basically one of the big things about the car industry is that they do an extreme amount of testing. They do a lot of testing in their systems, and they kind of self-govern themselves, and they're very, very strict about their testing. So in this particular case, they had a custom hardware, and that was one of the concerns. How does this custom software fit into such an important role powering some of this dashboard in a car? So the issues were basically developing a custom UI. As you may imagine, this is not a standard UI. What they liked was the developer base. So it's not necessarily developing apps, but being able to hire and go to market. And basically, the stack has a lot of moving bits and pieces that they already needed to have this done. Reliability was a missing piece. Testing this works in such an important role. Support for custom hardware, so they had the whole thing outsourced and built by somebody else in this case, and support for multi-screen. So those were the things that they were dealing with. Again, we have some modified and custom libraries. We have some hardware services because we wanted to add, say, support for other sensors, tire pressure, things like that. Modified system services, and then applications that were built internally in this case. And some other non-phone usages of Android. There's a company that put Android in the home security system. There's a company that put Android in a calculators to power their scientific calculators. There's even a company that is using it for tracking barges up in North Pole. And the attractiveness of Android is that these things sit up there in North Pole for months at a time with a very low amount of power. So Android was designed to consume very little power, and that was one attractiveness in this particular case. Microwaves, photocopiers, washing machines, these are all things that now run Android inside of them. So basically, at the end of the day, what's very interesting about Android is that it's open, it's a complete stack, and it's something that a lot of developers out there now have experience with, can build apps, can contribute to, and that's what makes it attractive to a lot of sort of non-phone usages of the system. So that's basically all I have. Thank you, guys. So the question is about the set-top boxes, how long it lives in a field. A lot of these set-top boxes sort of have, they build it in such a way that you can push the updates to them automatically, so the OEM can push an update. And that's actually a very attractive thing about Android, because you have a system to do that, OTA, right? To push the update of the entire platform. So what OEMs are concerned with is which version. So we sort of know what's coming up, but not really, with Honeycomb, with Ice Cream, and so forth. So if you're an OEM, you're sitting here today, and you're like, okay, are we gonna wait 6 months, 3 months, whatever the time span is, or are we gonna stick to Gingerbread, or stick to Froyo, or something like that, right? So those are the concerns, and those are big concerns, because, for example, do we need Flash? That's a big concern. Somebody's knows how to build UI in Flash, but it's not available until this version, and so forth. Second concern is, how do you make your IP be future-proof, right? So Google is going to release the next version. It's going to have new features, which are going to be awesome. We don't know what they're going to be, but they're going to be great. So how do you now plug your IP back into the new version? How do you maintain the code base? And that's where /vendor, for example, comes in handy in the source code. So now they kind of have that. At least Google is sort of starting to think about that, so that other people may have their own code in part of the source repository. So those are the concerns in this particular case. So the question is about the licensing issues and modifications to the code. So if you stick to, and I'm not an expert on this, disclaimer, but my understanding is that if you stick to the Android open source project, you're basically dealing with mostly MIT, Apache type licenses. So modifications you make to the code, you get to keep. And my understanding is that a lot of concerns right from the day one went into architecting the platform in such a way that your derivative work stays yours. Because, as you know, Eric Schmidt, right, when they acquired Android Inc., he said, look, our goal is many, many different devices. And that decision trickles down into a lot of technical things. For example, driver model, right? Like, why do we have libraries versus reading from a file? And that may have to do with GPL, LGPL sort of concerns as well. But having said that, I talked to some people at, I believe, Qualcomm. They have an entire division which is just dealing with licensing, and apparently that's a big hairy beast. There are hundreds of different licenses going on inside of the stack, and navigating that is a full-time job for a department, apparently. Well, so in terms of the Linux kernel question, that's a great question. It comes up always, and so people I work with are always like embedded developers. They want to modify the kernel and things, but technically kernel is not part of Android project. So there's a level of separation, right? When you download the source code, you don't download the source code for kernel, right? Your kernel is a separate project. When you download the source code for Android, as I said in that slide, for what it means to be open, you're actually downloading the pre-built version of the kernel. So as such, we're keeping that layer of abstraction between the kernel and the rest of the Android stack, because the kernel, you're correct, you don't have a choice. That's GPL code, right? So that's my understanding of that. So that's a lot of sort of technical decisions with libraries versus /dev and so on were done to enable that, so that we're not concerned with touching the kernel code too much. But that's as far as I know.